Hello viewers, in this lesson we will be discussing about special probability distributions. In the last lesson we were able to conclude the aspect of functions of probability, probability function, probability density function, and their respective or corresponding cumulative function. In this lesson we will be discussing about special probability distribution. Special probability distribution. If you are new to this channel, make sure you subscribe, you like, and you share the videos to your colleagues who are going to find it helpful. Without further ado, let's move into what we have in this lesson. Special probability distributions. Special probability distributions. So when talking about special probability distributions, we are basically having three special probability distributions. The first one is the binomial distribution. Binomial distribution. The second one is the Poisson distribution. And the third one is the normal distribution. Normal distribution. We'll be discussing two of the special probability distribution in this particular lesson, and we will be discussing about the last probability distribution in the subsequent lesson. So let's start with the first special probability distribution, which is binomial distribution. Binomial distribution. So binomial distribution and Poisson's distribution are a bit similar, but the difference between binomial distribution and Poisson distribution is that we make use of binomial distribution where n is less than 100. Where n is less than 100, but we make use of binomial distribution when n is greater than 100, that is for a very large number of population. That's where we make use of Poisson's distribution. That's where we make use of Poisson's distribution. So the binomial distribution says the probability of x equals r is equal, the probability of x equals r is equal to n combination r p raised to power r multiplied by q raised to power n minus r. N combination r multiplied by p raised to power r multiplied by q raised to power n minus r, where p is the probability of success q is the probability of failure. P is the probability of success. Q is the probability of failure, and n is the number of population involved, and r is the particular random variable in which you want to find the probability. So the mean, if you want to calculate mean, you can calculate mean from the particular data you given. Mean, which is mu, is given as NP. Mean is given as NP. The variance, in this case, the variance sigma square, remember variance is represented as sigma square, is given as NPQ. Why the standard deviation? Why the standard deviation is given as the square root of NPQ. Remember, standard deviation is just the square root of variance. It's just the first square root of variance. So without wasting much of our time, let's solve an example on binomial distribution. Let's have an example on binomial distribution. Example 1. So mind you, don't forget, I already told us that we need use of binomial distribution when the number of population is small, while we use Poisson distribution when the number of population is extremely large. When the number of population is extremely large and the probability of success and probability of failure are very small, So please take note of that. So before you, when you're giving the question, before you apply any method, either binomial or Poisson, check the number of population that is n, check the value, check as well the probability of success, and check the probability of failure as well. If probability of success is very small, then and the number of population is very large compared to those probabilities, then you should be using Poisson. But when the number of population is very large and the probability of success and failure is high compared to Poisson distribution, then you should use binomial distribution. So the first example says the probability that a political aspirant wins a world election is 1/5. Wins. Please take note of that word. Automatically, that should be your probability of success. That will be your P. The probability that it wins an election is 1/5, and that in decimal will give you 0.2. That's the decimal will give you 0.2. 10 aspirants contest in 10 wards of a local government area of a particular post. Automatically, your N, that is number of population, will be what? Will be 10. And it says find the probability that 1 exactly 4 aspirants win the election. And the second one says find the probability that not more than 2 aspirants will win their election. Solution to this: you are giving the probability of success, which is P, but you are not giving the probability of failure. Please take note, probability of failure is equal to 1 minus probability of success. Q is equal to 1 minus P. However, distribution either for binomial or Poisson distribution, Q is always equal to 1 minus P. So if your P is 0.2, automatically your Q is 1 minus 0.2, and that will give you what? 0.8. So the probability of failure is what? Is 0.8. That is the probability that you won't win the probability of not winning election. So the question says to find the probability that exactly 4 aspirants will win their election. The first question, exactly 4 aspirants. That's automatically the probability that x equals what? Probability that x equals 4, exactly 4. Probability that exactly 4 aspirants will win the election. And remember that P equals to x equals r, the formula, just want to record the formula, n combination r, p raised to power r multiplied by q raised to power n minus r. And automatically, the probability that exactly 4 aspirants will win, which is x equals to 4, will give us what? Will give us 10, because n is 10, 10 combination 4. Because in this situation, r is 4. 10 combination 4, p raised to power 4, and your p in this situation is what? your p is 0.2, 0.2 raised to power 4 multiplied by q raised to power n minus r. That and your q is what? Your q is 0.8, 0.8 raised to power n minus r. Your n is 10 and your r is 4. 10 minus 4. 10 minus 4. 10 minus 4. If you do this very well, you should be getting 0. However, you can write a combination. When you're having anything combination, 10 combination 4, although you can use your calculator to quickly get that one. In fact, I'm going to advise you to use your calculator to get that so as not to waste your time. But we want to complete it out first. 10 combination 4 is simply 10 factorial over 10 minus 4 factorial 4 factorial n factorial over n minus r factorial. R factorial, you can remember from our basic knowledge, multiplied by 0.2 raised to power 4 multiplied by 0.8 raised to power 10 minus 4. So if you do this very well, we should be getting 0.088. That should be giving us 0.088. That is the probability that exactly 4 aspirants win their election is going to be 0.088. 0.088. So the next question says, find the probability that not more than 2 aspirants will win their election. Question 2. That automatically the probability that X not more than 2 aspirants. Not more than 2 aspirants. That is definitely, it means that X must not be greater than 2 aspirants. Automatically it means X less than 2. X less than 2. But it says must not more than, so it will be less than or equals to. It can be equals to 2. It can be equals to 2, but it must not be more than 2. It must not be more than 2. Automatically it means X is less than or equals to 2. Probability of X less than or equals to 2. Probability of X less than or equals to 2. But this one is already in form of inequality. So for us to be able to compute our answer, we need to break it down to the number of possible probabilities. So if you want to break this down, we should be having probability of X, since X can be less than 2, so we definitely be starting from 0. Probability of when X is 0 plus the probability of when X is 1 plus the probability of when X is 2. You cannot have probability of when X is 3 because it says it must not be more than 2. So we are going to stop at 2. So we cannot compute for each probability. For here, your R is 0, here R is 1, here R is 2. So automatically, we have in form of n of combination of R times P raised to power R times P raised to power n minus R. So this should become 10 combination 0. 10 combination 0 times P. What are P? Our P is 0.2. 0.2 raised to power R raised to power 0 times Q. 0.8 raised to power n minus r, that's 10 minus 0. 10 minus 0 plus, this is for this, plus 10 combination r, which is 1, 10 combination 1 times 0.2 raised to power 1 times 0.8 raised to power 10 minus 1, 10 minus 1 plus 10 combination 2 times 0.2 raised to power 2 times 0.8 raised to power 10 minus 2. 10 minus 2. So you will definitely be using your calculator to compute that. If you do that very well, you should be adding. Your final answer should be 0.678. 0.678. So So you're going to get that with your calculator. It's as simple as that. So next we're moving to the second special probability distribution, which is the mind you, if you are being asked to calculate the mean, you can be asked to calculate the mean, standard deviation, and variance. So let me quickly do that in case you might be asked. So if you want to calculate your mean for this particular distribution, your mean mu, which I have given us the formula, is basically NP, and what's your N? Your N is 10. What's your P? Your P is 4.2. P is P is 4.2, which will 2, which will basically give us 2. So that's definitely our mean. So we want to calculate standard deviation. The standard deviation is variance first. We want to calculate variance sigma square, which is NPQ, and which is basically 10 times P, 0.2 times Q. Q will give us 0.8, and if you compute that, you should be having 1.6, and if you are going to be looking for your standard deviation, which is sigma, and that's square root of 1.6, square root of 1.6, that should be giving us 1.26. So that's about our binomial distribution. The next we will move into Poisson's distribution. Poisson's distribution. Poisson's distribution. Poisson's distribution. So Poisson's distribution says the probability of x is equals to lambda raised to power x, exponential minus lambda over x factorial, where lambda is equals to NP. So lambda is equals to NP, as we all know, P is equals to what? Probability of success, and as you can see, here you only need P, you only need probability of failure, you only need probability of success. So your mean in this situation, your mean mu is equal to NP as well. Your variance sigma square is equal to NP as well. Variance is also your NP, and this is equal to lambda. This is equal to lambda, and this is also equal to lambda. So automatically the standard deviation sigma will be what? Square root of lambda at the square root of NP. Please take note. In this situation, variance and mean are the same, unlike your binomial distribution. And standard deviation sigma is equal to square root of variance, which is square root of lambda, and that is equal to square root of NP. Example on Poisson distribution. Example. Example on Poisson distribution. So this example says 1 out of 1,000 people reacted to a newly manufactured vaccine against an endemic disease. If 3,000 people were treated with the vaccine, 3,000 people, automatically the number of population N is equal to 3,000. Can you see that here N is very large? So that tells you that you are going to be applying your Poisson distribution. When N is larger like this, 1,000, 2,000, 3,000 and the like, you are going to be applying your Poisson distribution. So once your N is very large and your probability of success is a very small probability, then you will be applying your Poisson distribution. So, and it says, we are not given, and it says find the probability that at most 2 people react to the vaccine, at least 3 people react to the vaccine. It says no one react to the vaccine as well, not less than 1 person react to the vaccine. I'll just be interpreting those questions out. I won't be writing everything in words. So the first one says at most 2 people react to the vaccine. So when we say at most 2 people react to the vaccine, it says that means X is less than or equals to 2. That is, it must not be more than that at most. That it must not be more than. It must not be more than what? It must not be more than 2. So automatically this is what probability of X less than or equals to 2. Probability of X less than or equals to 2. So the first one, it says at least 3 people react to the vaccine. At least 3 people react to the vaccine. That one it means that it must. If it says at least 3 people react to the vaccine, it can be more than 2. It can be more than 3 rather. It can be more than 3, but it must not be less than what? It must not be less than 3. It must not be less than 3. Automatically it means X is what? Is greater than or equals to 3. At least 3. At least it must not be less than 3, but it can be equals to or greater than 3. That's the interpretation to the second question. So the third one says no one reacts to the vaccine. No one reacts to the vaccine. Automatically that's probability that X is 0. Probability that X is 0. That is no one reacts to the vaccine. And the fourth one, it says not less than 1 person react to the vaccine. Not less than 1 person react to the vaccine. That not less than 1 person is same thing. It can interpret to at least 1 person. At least 1 person. So it means X greater than or equals to what? Or equals to 1. So that's the interpretation to those questions. But mind you, we are not given the probability of success. But we are given an information if you can use to calculate the probability of success. So automatically, probability of success must be, because if you check the question, it says 1 out of 1,000. 1, that is 1 person out of 1,000 people reacted. Automatically, the probability of success is 1 over what? 1 over 1,000. 1 over 1,000. That is 1 person out of 1,000 people reacted. So automatically, and you can see this is a very small value. This is a very small value of probability. That tells you that you are applying your Poisson distribution and not binomial distribution. I already explained that to us, the reason why we use Poisson sometimes instead of binomial. So this is what this in decimal will be what? 0.001. 0.001. 0.00. You can see it's a very small probability. So that's the probability of success. So in this situation, your lambda NP. What's your N? That's 3,000. 3,000 times P times 0.0001. So that's everything giving us what? Giving us 3. Your lambda is 3. Your lambda will give us what? Will give us 3. And which is what? Which is also equal to your mean. Because mean in this situation is NP, which is also equal to what? Variance in Poisson distribution. So now let's solve the questions, the problems one after the other. Let's solve the problem one after the other because we are beginning to get our lambda. Because you will need your lambda to estimate those values. Solution. The first one. The probability that x is less than or equals to 2. Probability that x is less than or equals to 2. So we can't, since it is an inequality form, we can't use the formula directly. We need to what? We need to break it down. So if we want to break it or want to split it to several probabilities, it is going to start from what? 0. When x is 0, right? Plus probability of when x is 1, plus probability of when x equals to what? Equals to 2. So we have been able to break it down successfully. So applying our formula, we already know our formula, recall our formula of this probability of x equals recall, let's say probability of x, let's put it that way. Probability of x in this situation is equal to what? Lambda raised to power x. Lambda raised to power x multiplied by exponential minus lambda over x factorial. Remember the formula. So in this situation, probability of x less than or equals to 2 is going to be what? When x is 0, that will be what? Lambda raised to power 0, and that's what? 3 raised to power 0. 3 raised to power 0 multiplied by exponential minus lambda, that's minus 3 over x factorial over what? Over 0 factorial plus lambda raised to power x, that's 3. X in this situation is 1, 3 raised to power 1 multiplied by exponential minus 3 over what? Over 1 factorial plus 3 raised to power 2. X here is 2 multiplied by exponential minus 3, that's minus lambda over what? Over 2 factorial. So you're going to be using your calculator to compute that. If you compute that very well, you should be getting 0.423 as your answer. 0.423 the answer. So the second, you can now move to the second problem. It says probability of x greater than or equals to what? Or equals to 3. Probability of x greater than or equals to 3. We are also going to be separating it into several probabilities. But if you check this very well, we have it greater than. If you want to put it in several probabilities, you don't know where to start. You don't know where to start. You don't know if you're okay. You start from 3. Let's say you start from 3. Okay, we know where to start. You start from 3, x equals 3, x equals 4, but we don't know where to stop. Will you be doing it up to where? Up to infinity? No, it's not possible. Definitely you'll be needing to transform that greater than into what? Into less than, so that you'll be able to do it up to a point that is limited. So that you'll be able to do it up to a point that is limited. So how do you now convert this greater than symbol to less than? Then it will definitely become 1 minus the probability of the number immediately less than 3, which is 2. 1 minus x less than or equals to 2. So that's how you can sum it. And even it's a very good advantage to us because we are really able to determine the value of probability of x less than or equals to 2. So you don't need to be going through those computations again. Just bring that value from there, then you have 1 minus 0.423. But if you wish to go through the computation, you can as well go through that. So if you're getting, you do that very well, you're getting 0.577 as your answer. So we go to the next problem, which is when probability of x equals 0. That is nobody. Of x equals 0. Nobody wants the election. Probability of when x equals 0. And that should be giving us what? This is defined already. It's already in equality. So it's not in inequality. So just apply the formula. So we have 3 raised to power what? R is 0. 3 raised to power 0 multiplied by exponential minus lambda. And lambda is what? Is 3 over x factorial. Over what? Over 0 factorial. Over 0 factorial. So if we do that very well, should be having 0.05. 0.05 as your answer. You're going to need to do that with your calculator. So the fourth question IB says not less than one person reacts to the vaccine. Not less than one person reacts to the vaccine. That's automatically probability of x greater than or equals to 1. Probability of x greater than, because it's the same thing as saying probability of at least one person. So we needed to convert this greater than to less than as well, as we have done here. So converting that to less than, what we have 1 minus probability of x less than, what the immediate number less to 1, which is 0, less than or equals to what? Or equals to 0. Less than or equals to 0. But it will definitely be equals to 0. We just say probability of x equals 0. 1 minus probability of x equals 0. Because we cannot have when x is less than 0. That will be negative. That will be minus. In this situation, you cannot have x cannot start from negative. So it is going to be what? Probability of x equals 0. So and we have what? We have determined probability of when x equals 0 in the previous example. So just bring the value from there. That will be 1 minus 0.05. And that should be giving us 0.95. So that's a good example to Poisson distribution. We also be solving one more example on Poisson distribution before we come to the end of the lesson. Let's solve one example on Poisson distribution. Even with this last this just completed example, you should be able to tackle any problem on Poisson distribution because it has touched every area of Poisson distribution. So this example says 4.2%. We are giving that probability as a percentage. So that's the first thing that should come to your mind. 4.2% of the clocks produced by a machine were found to be defective. Find the probability that 5 out of 1,000 clock would be defective. That last statement, 5 out of 1,000, that last statement already giving you the number of population. So automatically the range is equal to what? 1,000. And the first statement has already given you probability of success, which says 4.2% of clocks were defective. So automatically your probability of success not be is equal to what? 4.2%. And converting 4.2% to fraction, we have what? 4.2 divided by 100. Divided by 100, which gives you what? Which gives you 0.002. So we are able to determine our probability of success small p. We are able to determine our n. So we can easily determine our lambda. So your lambda is going to be what? 1,000 times, that is NP. NP which is equal to 1,000 times 0.002. And that will automatically equals 2. So our lambda will be what? Our lambda will be 2. So we will be able to determine lambda, we will be able to determine our n, so we can now solve our problem. So the first question says, find the probability that, okay, it's only one question, find the probability that 5 out of that 1,000 were defective. That's automatically probability of x equals 5. It is direct probability that x equals 5. Which will give us what? Which will give us, okay, let's write the formula. Lambda raised by x multiplied by exponential minus lambda over x factorial. And that's automatically what? That's the value lambda raised to power, that's 2 raised to power 5 times exponential minus 2 minus lambda over x factorial. X is 5 over 5 factorial over 5 factorial. So we do that very well. We're getting 0.036, and that's the answer to that. So that's going to bring us to the end of this particular lesson. These are special probability distribution, but this is not the last aspect. We are still left with normal distribution. So in the next lesson, we'll be starting from normal distribution. If you are new to this channel, kindly make sure you subscribe, like, and share the video to your colleagues who find it helpful. Tutor Bosun is here. Thank you.